Hello, welcome to this tutorial on how to create an ASCOM device driver. ASCOM is a marvel for developers in that it allows any client program to connect to any hardware on a telescope. Hardware manufacturers create ASCOM drivers for their hardware, and they will then work with existing astronomy client applications such as SkyMap and Maxim DL. For example, if I made a new mount that I wanted to market, I would have to write an ASCOM driver for it. It would then work with software like SkyMap and Maxim DL without those software vendors having to change their software. It's very powerful, and without it we would be in a mess where we used to be some years ago, where every single piece of client application had to write device specific code, and it caused so many problems. ASCOM makes life much easier for everybody. So there's a few bits of toolchain we need to sort out first. First of all, you need Visual Studio. The Express edition we can download from Microsoft. Once we've installed that, we need to get Visual Micro, which allows us to create Arduino programs inside Visual Studio, which is much easier than using the Arduino interface. You need to install this after you've installed Visual Studio. Then we need the ASCOM bits. So on the ASCOM website we need to download the ASCOM Platform 6 Service Pack 1. Once we've installed that, we then need to install the ASCOM Platform Developer components. We do this after installing Visual Studio because it'll create some templates in Visual Studio that save a great deal of time. So for the next step we need to try and have a look at the structure going on here. Now, if I'm making a filter wheel, there's going to be some hardware. There's going to be some filters inside a box, some sensors, some stepper motors, that sort of thing. That's going to be hardwired to our Arduino, which is going to control the stepper motors and the sensors. Now, I'm not doing the hardware bit today. That's not relevant to this tutorial. I'm just going to make a sort of a fake filter wheel inside the Arduino, which doesn't actually connect to any hardware. That part is outside the scope of what we're talking about today. The Arduino can only connect to the computer via a serial port. So there's a serial port, and then on the PC we have our ASCOM driver, which communicates to the Arduino. Your ASCOM driver is what we have to write. The stuff in green, therefore, is all device specific, in that the person making the filter wheel is responsible for the driver and the communications between the driver and the Arduino. Outside of the device specific area is the client application. This can be Maxim DL or any other imaging software. That communicates to your ASCOM driver through the standard ASCOM comm interface. So where do we start? Well, let's start with this bit here, the Arduino itself. I'm going to start Visual Studio. When you have Visual Micro installed, you get a couple of drop-down lists. This one here tells us the target board that we're compiling for, and this one here is the COM port that device is attached to on my computer, which in this case is COM3. So we say new Arduino project, and I'm going to call it filter wheel Arduino. Doesn't matter what that's called, no one's ever going to see it. So that opens up a simple stub program. Now I'm just going to copy and paste in the code here. If I can get copy and paste to work. Now this code, first of all, it opens the serial port and it flushes the serial port. That's in the setup part that the Arduino runs when it gets started up. In loop, which is run continuously by the Arduino, all we have to do is listen for messages on the serial port. So if there's some information available on the serial port, we read that information until we hit a hash. More on the hash later. What we have to do now is invent our own little protocol, which is going to operate back on the diagram between your ASCOM driver and the Arduino. And this can be any set of commands you feel like. I've decided to use get filter to get the current filter, and filter 0123 to move the filter to a particular position. So if it receives a get filter command, it just sends back the current filter. Current filter is a global variable that we use to store inside the Arduino what filter position we're at. It sends the current filter and then it sends a hash. I'll come back to the hash. If we ask it to move to filter 0, filter 1, filter 2 or filter 3, it calls this function move filter. Now move filter is where you'd go off and run the stepper motor to move the filter to the next position. We're not writing that today, so we'll just pretend and we'll just stick a delay of 2 seconds in. Move filter then sets current filter to whatever value it was called. So for example, if I send filter 1 down the serial port, it'll call move filter with a 1 and it'll set current filter to 1. It's very, very simple, and we don't want to get into all the hardware stuff today because we're just trying to understand the ASCOM side of things. So if I press play, it'll go off and compile that, and once it's compiled it, as we can see in this little window down here, it uploads it to the board and it's done uploading. If we now open the serial port monitor, we can ask it to get filter, and we can see it's returning a 0 because when the program starts, current filter is set to 0. If I now say filter 1 please, we wait a couple of seconds and then we'll do get filter, and we'll now want filter 1. If we say filter 2, wait a couple of seconds, we're now on filter 2. I'm just going to put one more line of code down here. If I just do that and compile, you'll see the point in a second. If I say get filter, I've got a 0. If I say filter 1 hash, we can see when the delay is over, it punches something back to the serial port. This is going to be used to tell the ASCOM driver that we've finished moving. So if I now say get filter, we're now on 1. If I say filter 3 please, we'll wait a little while, it comes back with a confirmation. We can now say get filter again, and we're on filter position 3. That's all the code that you need in Arduino for this purpose. Obviously the comment here, do stepper motor stuff, encapsulates a whole load of calls to stepper motor drivers and sensors to find out what filter we're at. But as I say, that's entirely down to how you've built your hardware, and it's nothing to do with communicating with ASCOM. So that's all we need in this simple setup. Now, going back to our diagram, as I say, today we're just faking the hardware layer, and we've written some code in the Arduino that receives and responds to messages on the serial port using a little protocol that we've invented ourselves. Now, this clearly demonstrates how good the ASCOM standard is. If we were marketing this this filter wheel, and we wanted it used by Maxim DL, in the old days we'd have to contact the man who makes Maxim DL and tell him to program in that protocol that we've just invented. Now, Maxim aren't going to be interested in doing that with every single filter wheel that comes on the market. And furthermore, if there's a bug in their implementation, they need to release new software to fix it. Or if I make a change in how my protocol works, then Maxim are going to have to release yet another new version to support that. It's a ridiculous mess, and ASCOM makes it much easier. So the next thing we need to look at is the ASCOM driver itself. So I'm now going to open up another copy of Visual Studio. This time I'm using Visual Studio 2008, but that's entirely just so it's a different color, so you can realize which one I'm looking at. So I'm now going to say a new project. When you install the developer components, it sets up these lovely templates. So there's an ASCOM device driver wizard. So this is our test filter ASCOM. If we say OK, we now need to say what device it is that we're writing a driver for. This could be a camera, a dome, a filter wheel, a focuser, a camera rotator, telescope, safety monitor. But today we're doing a filter wheel, mainly because that's the simplest one. And we need to give the device a name, and this will appear to the user. So we'll call that filter funky filter wheel. And that's what's going to actually appear to the user. So we'll create the funky filter wheel project. Now, the first thing that happens is this yellow bit here. Before building, implement the interface by putting the cursor at the end of the line and pressing return. What that means is we need to open driver.vb, scroll down a bit until we see this line here, click on the end, press return, and that's it. That just makes sure that the whole thing is implemented properly. We'll now save it. You'll notice I'm saving this directly to my Google Drive folder. This means that my development is immediately backed up online and I never lose it. That's good because you do not want to lose development that you've spent hours slaving over. If you lose the source code, rewriting it is very boring. Trust me, I've done it. So we'll say save. Okay, so as you scroll down, you can see there's a lot of code put in place already by the template. This saves us a great deal of effort. If we have a look at the documentation here, we can see that the filter wheel interface members, there's not many of them, and the one that's most interesting is position, which sets or returns the current filter wheel position, and that's the one that we're most concerned with today. If, for example, you look at a telescope, you'll see there's a humongous number of different things to implement. It takes a long time to write an ASCOM driver for a telescope mount, trust me. You've got to deal with tracking rates, side appear, go-tos, guiding, pulse guiding, right ascension, declination. There's a lot of stuff to do, whereas with a filter wheel, the only interesting thing is the position of the filter. So let's just refer back to our diagram one more time. We've written the Arduino bit, we're now dealing with the ASCOM driver. Those properties, such as position, are the properties that the client application actually calls. So let's go back to our code here. The first and possibly the most important property in any ASCOM driver is connected. When the client application wants to use your hardware, it calls the connected property and sets it to true. So when that happens, you need to actually go and then in the driver connect to your Arduino via the comm port. So how are we going to do that? Well, first of all, we need an object to store a comm port in, which we'll put here. Now, ASCOM actually provide a serial port wrapper, which is very good, and they recommend you use it. So obserial is the name of my serial port object for the rest of the program. If I come back down here, we need to open the serial port when the client application tries to connect. So I'm going to just cheat again, copy and paste in a bit of code. So if the client application tries to set the connected property to true, we're going to instantiate the serial port, set the port number to 3. That's hardwired in because I know it's 3. You're supposed to use the ASCOM settings to do this, which are stored in a dialog prompt, which you'll see in a minute, but I'm just going to ignore that today because that's an extra complexity we don't need to worry about. We set the speed of the port to 57600, which is, if we go back to our filter wheel code, that's what we set it to on the Arduino, so both ends of the serial port are talking at the same speed. If, on the other hand, the client application has set connected to false, then we need to serial connected set it to false, and probably tidy up by possibly disposing of the serial port object, but we're not going to do that. Now, if the client application wants to know if it's connected or not, i.e. it tries to get the property, as you'll notice with these properties there's a bit of code if the client application is trying to get the property, and another bit of code here if the client application is trying to set the property. So what it's doing is returning is connected, and that is a private property. If we go to the definition, at the moment it's returning false, but you'll see there's one of their handy to-dos here, and that means we have to do something. And I'm just going to put in another bit of code here, and essentially this piece of code is checking if the serial port object is instantiated. If it is and it's connected, it will then return true, otherwise it will return false. So it will return false if the serial port hasn't been instantiated yet or it's not connected. Okay, so that's that bit. I'll just save that. I'll just there are a couple of other properties worth looking at before we move on to the main one. Name, where's name? Here's name. Name is just the name of my filter wheel, and normally I just put return donk like that. Names is the names of the filters. If we go back here, we'll see names. It's the name of each filter in the wheel. I'm not implementing that today because not a lot of imaging software uses that. They usually sort of manage the filter names themselves. So, but if you want to do that, that's fine, but we can ignore that for the purposes of what we're doing today. Right, now we come on to the most important property, which is position. This is how the client application communicates the position of the filter. There's a get and a set, so if the client application tries to get the position, we need to return the current filter position. If the client application tries to set the position, then we need to move the filter. So how do we do that? So if you remember back in our example, back in the Arduino code, if the Arduino code gets the message get filter on the COM port, then it returns the current filter number. So we need to put some code in our ASCOM driver that does that. And here it is. So the serial, because it's already connected, the serial port will be alive and working. So we do a command to transmit get filter down the serial port. We then set a string and we receive terminated hash. And this is the whole reason for the hash. In my personal protocol, I've decided to terminate everything with a hash so that both ends, the Arduino and the ASCOM driver, know when they've got to the end of a message. We then get rid of the hash, and that should hopefully just leave a number, 0, 1, 2, 3, which we return. So when the client application wants to know the position of the filter, it calls position in the ASCOM interface. Our driver then sends a message down the COM port, receives a message back, and returns that number to the client application. This code is the device-specific code inside our ASCOM driver. The client application doesn't know, doesn't care, will never see this code. It's abstracted. So whatever filter wheel driver the client application is using, all it does is call position. And each specific ASCOM driver for each filter wheel on the market will have some code in that does this. Now, set is the other one. So when the client application wants to set the position of the filter, it sets the position property, and we need to do something down here. Again, if I go back to my Arduino code, if we wanted to set the position of the filter, we call filter O, filter 1, filter 2, filter 3. So let's go back in here and put a bit more code in. So I'm going to make a string and I'm going to put the word filter in it. I'm then going to tack on the end of the string the value that the property is being set to. I'm going to transmit that down the serial port, and then I'm going to receive something. Now, as you may remember, when we were doing this, when I said filter 1, when it had finished setting the filter, it returns 0 hash. So back in our code here, it's going to transmit filter 1, and it's going to wait until it gets something back, i.e. something ending in a hash. So when the client application wants to set the position, it sets the position property to say 3. We're going to create a string that says filter 3, shove it down the COM port, and we're going to wait until we get something back, and at that point control is returned to the client application. So we'll just build that. It doesn't take very long to build. So back on our diagram, we've got some Arduino code controlling the hardware, and we've now written an ASCOM driver that communicates via the serial port with the Arduino code. So outside of the device specific area is a client application which uses that ASCOM device. So we need to open our client application. Now we'll go to camera control. Now I'm using the simulator camera because I haven't got a real camera attached. We press setup filter and we say advanced. We get the typical ASCOM chooser, and we can find funky filter wheel in the list. We can set the properties, although as I said earlier we're not using that yet because I didn't want to complicate things. And we say OK, and we say OK, and we connect. By pressing connect, Maxim's now gone and connected to our ASCOM driver. It did that by setting connected to true. And when it set connected to true, our code actually connected the serial port. So in Maxim, if I now try and change the filter, you get a little egg timer, and Maxim now knows it set the filter wheel. Change it to green, round and round it goes, and it's changed. Doesn't look very impressive, but don't forget, when that filter wheel's changed, Maxim is calling something in our ASCOM driver. It's setting the position property. The position property is sending a message via the serial port down to the ASCOM driver. Let's go back to the diagram. So we change the filter in here. That sets the position property. By setting the position property, some code is run that sends a message down the serial port to the Arduino saying set filter to number 3 please. Arduino will then manipulate the hardware layer to move the filter to position 3. The Arduino will then send a little acknowledgement back to the ASCOM driver to say I've finished, and then the ASCOM driver will then allow the client application to continue. There's a lot going on, and it looks pretty seamless when you're back in your client application flicking the filter wheel around. The next question is what happens when it goes wrong. The filter wheel is a pretty simple, there's not much code. So there's not much to go wrong, but if you're building a telescope mount driver, then there's a large amount of code and a great potential for you to have a bug that you need to debug in your driver. So how do we do that? Well, in Visual Studio, you know perfectly well you can set a breakpoint, but Visual Studio we're not pressing play in Visual Studio, we're going off and starting Maxim. So what we need to do is tell Visual Studio to start Maxim when we want to debug. So if we come in here and get the path to Maxim, pop that in there, and stick the path in there as well. Save that. Now let's just go back in here, just get rid of that breakpoint for a second. If we press play now, it actually starts up Maxim DL, which is very cool. Go into the camera control, connect, it's connected now, change the filter wheel, it's all still working. If I go back into our code now and I stick a breakpoint here, go into Maxim, change the filter, it hits our breakpoint. Now, Maxim DL is not responding at the moment. It's waiting for this code here to finish. So we can step through the code So we can step along and we can see that we've built our string with filter O in. We transmit that to the serial port and we receive something. And if we now allow the program to run, Maxim DL has now come back to life. Change the filter again, bang, we hit the breakpoint, press play, off we go, and Maxim's changed to red. This is very powerful in that it allows us to debug the driver using a client application, because different client applications sometimes do things in slightly different ways with ASCOM commands. All of them are legal, but sometimes you need to be debugging to find out exactly what goes wrong. So I can press stop, change some code, press play again, and off I go. Now at this point I need to make a little aside about ASCOM drivers and multi-threading. With a filter wheel, the chances are you've got one application connecting to the filter wheel and there's only one property to worry about. Compare that with a telescope mount where several applications may connect to the telescope mount at the same time. You need to manage what's going backwards and forwards on the serial port more carefully, and there's a page in the ASCOM developer documentation which deals with this, and you need to read it carefully. So just to recap, to finish off, a typical filter wheel will have a hardware layer. In our system, the hardware layer is faked by a short delay, and you have to go off and write your own stepper motor stuff. The Arduino will need some code to manage communications between your ASCOM driver and the Arduino itself. The commands that actually go up and down the serial port are up to you, as I've said before. So this bit's managed in here in the Arduino code. You then need to write an ASCOM driver that answers those calls and abstracts that protocol from the client application. So, and here's our ASCOM driver. The ASCOM drivers, as I said, are very easy to make from the templates, but you have to go and manage all the serial communications yourselves. And finally, well, I can now go and use any piece of imaging software with the filter wheel I've just made, and I don't need the man who made the imaging software to do anything special on my behalf. And that's the magic of ASCOM. Now the final step is what happens when you want to give your ASCOM driver to somebody else, i.e. you've made a product, you're going to have to send a disk out with it that's got your ASCOM driver on it. To do that you need to build a setup. I'm just going to touch on this very briefly, but it's pretty simple. ASCOM support a piece of software called INO Setup, which builds setup programs, so takes all the work out of it. You need to install INO Setup on your computer. It's free, so that's no problem. In your ASCOM developer tools, you'll find the driver install script generator. You run that, and you fill in the box. Here we've got a .NET. We're doing a .NET assembly. It's all great, and then you press save, and it then opens up the script in the INO Setup compiler, and you compile that. And it doesn't work because we got the wrong path in there, because I haven't actually built the release version, but don't worry about that. And we can play it. Now, I tend to get this error as well. I don't quite understand it, but I know if I remove that line from the INO Setup, it works. Now, if we run it now, you get a setup wizard. So that's how you deploy your applications. It works pretty well, and I've used that a number of times to send drivers to other people I've been writing stuff for. Okay, so I think that's everything. Hopefully that's given you a starter for 10 on how to create an ASCOM driver, which interfaces with an Arduino driven piece of hardware. Good luck and have fun. Good night.